Hello, my name is David Wilson. I'm the product manager for pressure and temperature products at SOR. Today I'd like to discuss the newest addition to our regulator product line, the 1201 high pressure regulator. So on the agenda for today, I'll be talking about the features and benefits that make the SOR 1201 HP regulator stand out. We'll go over the specifications of the regulator. I'll discuss how the regulator works, its principles of operation, and then we'll talk about a couple applications that we see these regulators used in most often. We'll also cover some of the competition and then how to order the regulators, what information you might need to know in order to place the order correctly, and then just a couple frequently asked questions that have come up. We'll discuss those questions and the answers. So for the features and specifications of the 1201 high pressure regulator, first off, we'll talk about basically what is this regulator. So the high pressure regulator is an extremely durable product. It's designed for those rugged environments with high pressures and high pressure drops as well. So anything over 2,000 psi or 1,500 psi, generally that's where this regulator would be used. It could be used up to 5,000 psi applications, but anywhere where you're getting those high supply pressures and you want to regulate it down to the 225 psi range and lower, that's really where this product is used. So the features and benefits. The first one, there's 3 outlet ports on this regulator. Generally what you'll see is a pressure gauge put in one outlet so that you can see what the actual outlet pressure is. This is also used for calibration of the set point. And then you've got 2 other outlets that can control pneumatic devices. You could plug one up and only control one device, or you could use all 3 outlets and control 3 different devices if you wanted to. The second feature is a tamper-resistant adjustment screw or a T-handle. You have your option of the 2. Basically what these are used, they're just there to allow you to lock in your set point so that any sort of vibration or movement of the regulator isn't going to affect the output of the regulator. The third feature is a seat block which contains 4 seats. This is most useful whenever you're doing maintenance or inspection of the regulator. You might notice that your seat is a little worn down. Maybe you need to replace that seat. Well, what we've done with our seat block is we've put 4 different seats on each side. So whenever one seat gets worn down, you don't have to replace the whole thing. You simply just rotate the seat block 90 degrees, and you've got a fresh new seat to use without buying a new replacement. And then the fourth feature is a stainless steel version that is used for NACE applications or corrosive environments. This stainless steel version will be coming soon. It is not launched yet, but it is on the way. So for the basic specifications of the 1201 high pressure regulator, I'll touch on a few of the more important specifications, but you've got your process connection sizes are 1/4 inch MPT connections. One of the biggest differences between the brass and the stainless steel version is going to be the spring case vent. The brass version has 4 holes placed in the spring case vent to allow any gas from a failed diaphragm to escape the regulator. The stainless steel version, on the other hand, has a tapped exhaust on the spring case vent, which is mostly needed for those NACE applications where regulations require you to vent any gas to a safe location away from the site. So you can use this tapped exhaust to run piping to a verified location. And so then moving on, we've got 5 different output ranges for the HP regulator. You can go from anywhere to 0 to 225 psi all the way down to 0 to 30 psi. So this really just depends on what you're trying to control, what pneumatic device, what its ratings are for its supply pressure. And then also, if you're trying to do some stage regulation where you're regulating down in stages, you might not go all the way down to 0 to 60. You'll go down to 0 to 225 first, and then you'll have another regulator drop it down to 0 to 60. And then also, the maximum supply pressure of these 1201 regulators is 5,000 psi, as I previously mentioned. The flow coefficient of the regulator is 0.18. The temperature range is -40 to 225, so that covers basically any environment that you might be in, from the very cold to the very hot. Weight about 3.25 pounds. The operating media, the operating media of these regulators is gas. There's no liquid that can be used with these regulators. It's all air, inert gas, or natural gas. And then the materials of construction, really that's the biggest difference between the 1201S and 1201B is the construction. So the S is going to have NACE compatible materials while the B isn't NACE compatible but can still be used in natural gas applications. So now that we've covered the features and the specifications, really I'd just like to inform you on how the regulator actually works, how it's regulating the pressure. And so that's what we'll do here. So these regulators are directly operated, and they register the downstream pressure through the body on the underside of the diaphragm. So by direct operation, what this means is that there's really three elements to the regulator. There's the measuring element, which is the diaphragm. There's the loading element, which is the control spring. And then thirdly, there is the restricting element, which is the seat block and the supply nozzle. So these three elements together are the really how the regulator operates, is using these three elements with each other. So another advantage of a direct operated regulator is that it's a lot faster response time as opposed to a pilot operated regulator. So for liquid level controllers and dump valves, response time is vital. And that's why you see this regulator used so often with those other devices, because it's direct operated and it has a quick response time. So really, how all these three elements that I mentioned before work together is you'll have downstream demand, which affects the output pressure demand on the regulator. So, for example, when the downstream demand decreases, the output pressure will rise. Because they're closing off a valve or something and that pressure is building up and it's increasing the outlet pressure of the regulator. So when this outlet pressure rises, what it does is it pushes up on that diaphragm and pulls up on the seat body. When that seat body pushes up closer to the supply nozzle, it's restricting the flow coming out of the nozzle, which then restricts the flow downstream. Eventually, this flow will stabilize at the set point pressure that you have set on the regulator. On the other hand, if downstream demand increases, that means the valve has been opened or the pneumatic device is asking for more flow. And the result of that is the output pressure will fall underneath the diaphragm, which allows the diaphragm to push the seat body lower. When that seat body pulls away from the supply nozzle, more flow is allowed through the regulator in order to meet the demands of the devices downstream. So eventually this will also stabilize at your set point. And so really it's a back and forth game of what's demanded and how the regulator reacts. But that's basically how it works. So now that we know how the regulator works, we'll talk about some of the specific applications that this regulator is intended for use in. So here's a list of some example of applications. A natural gas instrumentation column, which is pictured in this slide, is one use for it. And really, in this column, the regulator, what they're doing in this column is they're collecting all the devices needed to do staged regulation, and then they're taking the output of this column to their pneumatic devices. So this really centrally locates all of the devices needed in some sort of staged regulation. On this column, you can see they've got an air filter regulator at the top. They've got a brass regulator below the air filter regulator. And then they've also got a stainless steel regulator up here feeding a catalytic heater. Which leads me to the second application on this slide, which is the catalytic heater. And catalytic heaters require a regulated supply pressure in order to perform at their specifications. So the stainless steel regulator is really providing that regulated pressure with no fluctuation so that the catalytic heater can perform its duties. The third application on this list is control valve automation, which we'll see in the next slide. The output of the HP regulator will often be used to control a liquid level controller, which then controls a pneumatic control valve or a dump valve. And so I'll just move on to that next slide so we can get a better look at those applications. So this is the biggest application that we see for the HP regulator. Really, the products in this slide that you can see in this illustration are all part of a separator package. And by offering the 1201 HP regulator, SOR is prepared to provide the entire package needed for separator applications. So just getting more into detail on this illustration here, what you can see is we've got a separator tank, and the oil is being separated onto this side of the tank and then dumped to a different storage tank, while the water is being dumped to a water storage tank. Now, during the separation process, there is natural gas that is released, and it is sent on to a gas processing plant. So what we see most end users do is they'll take the pressure off of this pipeline to the gas processing plant, and they'll run it through the HP regulator for the first cut in a staged regulation. The second stage of regulation would be a 1200 series pressure regulator, like a 1227 or 1230, which SOR has not launched yet but is on the way. And then the final stage would be a 1267 air filter regulator, which not only regulates down the pressure to its final output pressure, but it also filters the air or the gas, in this case the natural gas. It filters it so that there's not any sort of gunk or moisture or anything that can build up within the 1400 series dump valve or the liquid level controller. So this illustration is just how we show staged regulation, and the reason that you need this staged regulation is because it's just the natural law of physics that dropping a high pressure to a low pressure is going to decrease temperature. When you're doing too big of a pressure drop or too large of a pressure drop, what you'll see is you'll start to see freezing or cavitation within the regulator. So the answer to that is to break it down into stages, where you do a little bit of a pressure drop here, a little bit of a pressure drop there, and then a little bit of a pressure drop there. And by breaking it down into stages, you're allowing that gas or that fluid to kind of balance out its temperature in between the stages so it can heat back up before it gets to the next stage, and you're not getting as much freezing. Sometimes we'll see people put heaters on their line, or they'll put heaters on the regulator itself in order to combat this freezing as well. So speaking of sales orders, how do you order? What do you need to know in order to order these regulators? So what you need to find out before you can choose the model of the 1201 HP regulator is you'll need to find out the type of media. Like I said, you got to make sure that this isn't going to be used for liquid media applications. It's only for gas applications. Second, are there NACE requirements? If there are, you will need to specify the stainless steel version, which can be NACE certified and is corrosive resistant. The third thing to know are tapped exhaust requirements. This kind of goes hand in hand with the second option. If it's NACE required, it's most likely going to require tapped exhaust, and which will mean you'll need a stainless steel version. Now, it might not be NACE required, but they might still require tapped exhaust. In that case, you'll still need the stainless steel version because the brass version does not have a tapped exhaust. Do they prefer the T-handle? If it's preferred, you'll have to order the T-handle as a separate part item. It's listed in the catalog. But if it's preferred, that's something you'll have to order as a separate list item, and we'll ship it with the regulator. Supply pressure. You've got to make sure that that supply pressure is within 5,000 psi within our specs. And then the desired output pressure, really this is how you choose the spring and the output range. What pressure do they need it to output to? Pretty self-explanatory. So really that's what you need to know. After you know those things, here's how you order. Here's the model tree. Very simple. You've got two choices. You choose your material, and then you choose your output range. And then as you can see, we've listed the part numbers for the T-handles down here. 1201-BH&D is the brass T-handle, and 1201-SH&D is the stainless steel T-handle. So this is a very, very simple model tree. There shouldn't be much confusion with how to select your model. Okay, and then a few frequently asked questions that have come up I've listed here. So what are the list prices of the T-handles? Both the brass and the stainless steel T-handles will list at $7, so there'll be a $7 list price adder for those T-handles. Does SOR offer a repair kit for these regulators? Much of the competition does offer a repair kit, and so do we. The repair kits are there's a separate kit for the brass model and a separate kit for the stainless steel model. They're going to include spare diaphragms, they'll include seat assemblies, and then they'll include a couple gaskets and other small parts. For the brass, the repair kit's going to cost $35 list price, and for the stainless steel, the repair kit will cost $54 list price. So, can I change the outlet pressure range of my 1201 pressure regulator? I think I've mentioned this multiple times throughout the presentation. Yes, any control spring can be swapped out with any other control spring in these regulators. This allows you to easily change the output range of the regulator if you're switching applications or if you're filling an order that requires a different output range. So finally, for more information about the 1201 high pressure regulator, please contact the factory. We've also launched a press release on SOR's website. The catalog is online on SOR's website if you'd like to see that. Both of those resources will provide you more information. For any other questions or inquiries about price or delivery of the SOR 1201 HP regulator, then please contact your customer service representative and they'll be happy to help you. So that's everything that you need to know about the SOR 1201 high pressure regulator. This regulator is being added to our pressure regulator product line, and on top of that, it's also starting to complete our separator package product line. As I've mentioned multiple times in this presentation, we offer control valves, we offer liquid level controllers, we offer air filter regulators, now we offer high pressure regulators, and we will be adding to that pressure regulator line shortly in the future. Really, what we want to do is we want to be that one-stop solution for all the end users out there who require separator package regulators and products. So anyways, thank you for joining, and I appreciate your time. Please feel free to contact me or the factory if you have any more questions. Thank you.